Good morning, everybody, or hello, whatever time it is where you are and what you're watching. What time you're watching? Crazy. Anyway, so hello, everybody, and this is Saltash Maths Tutor, and we are going to be doing some Pythagoras. This is aimed at everybody, foundation or higher. It's the basic concept of how to manipulate a triangle and find the sides. I will be doing ones on cosine and sine rule and all that sort of stuff, but right now I just want to get the basics of Pythagorean theorem and the formula you will have learnt at school weighed off. Okay, so here we go. Don't forget though, everybody, down here's the important stuff. Like it if you like it, comment. I've had a few comments on other videos and I'm more than happy to respond to those. First thing we need to get a handle on is the triangle that we're talking about. And everybody, well, it's his fault. Him. There's Pythagoras, old bloke in a toga. He is the one that came up with this theorem, which is actually, I guess, quite neat, is the way of describing it. It's an interesting, oh god, what am I talking about? Interesting, here we go. In a right-angled triangle, a right-angled, everybody, purely means that this angle here with the sine, this sine here, which looks like an R or makes the corner a box, however you want to view it, means that that angle is 90 degrees, and that makes it a right-angled triangle. And Pythagoras' theorem only applies to a right-angled triangle. And what he said was this, that if I have three sides, and we're just going to label them up as A, and as B, and as C, he said that A squared plus B squared equals C squared. And there's all sorts of diagrams that explain that. In fact, if you look in some detail on the picture of Pythagoras, there in fact is one of the graphical explanations of Pythagorean, the formula itself. I'm not going to go into that in any great, in fact I'm not going to go into that. I'm just going to prove the formula by giving you an example, and then we're going to do some exam questions. So everybody, A, B and C, and I might be a bit disjointed for the next 30 seconds because I've just had to pause making the video because my mum was on the phone. And hey everybody, if your mum phones you up, you should always answer the phone. But hey, here we go. So I think we're going to be proving A, B and C. So we're going to add some numbers in here, and my numbers are going to be, we're going to have 3 and we'll have the 4, and let's see if we can prove our A squared plus B squared equals C squared thing. So there we go, I've written up A squared plus B squared equals C squared, and all I'm going to do is I'm literally just going to punch the numbers into the formula and see what comes up. So here we go. So well, that's the A equals 3, so I've got 3 squared. I'm doing this bit of the formula. Okay, I now want to do this bit of the formula. Well, I've got a B, that's got the value of 4, so we're going to put 4 squared in there, and that equals C squared, and C is what I'm after. I'm after C, that's that bit there. So if you want to, you can break out the calculator, and for those of you that aren't quite sure where the square button is, it is just there, or it'll be something similar on your calculator. So that is going to be 3 squared. Well, you can do it in your head if you want to. 3 squared is 9, plus 4 squared is 16. And so what's 9 plus 16? Well, that's 25. But this is the bit that sometimes people get a bit hung up on. What we're saying then is, because that, remember, equaled, I'm going back up here now, let's just highlight this, A squared, which was that, plus B squared, which was this bit here, equals C squared, which is that bit there. we've now put in the numerical value 9 plus 16, and we've come up with that equals 25. So what that means then is that c squared equals 25. c squared equals 25. So you can put that into your calculator, and you are looking for the, we don't do that. You will either know that the square root of 25, because we just want c, I keep using the rubber here, we want c equals, well, it's the square root of 25, or you can do that on your calculator. On this particular picture, and your calculator will be whatever it is, the square function is there, but square root of 25 is 5. So we can put 5 in there. And that's Pythagoras' theorem. So if I was to go through and just say that in simple terms, what we're saying is this: a squared plus b squared equals that c squared, and that is it. So let's work through another example, which will be slightly faster, and this is the triangle that I've been presented with, and we want to know what this length is here. So I'm just going to label things up, and I'm going to call that A, and call that B, and call that C. Now here's another thing that you don't need to worry about. It doesn't matter which way round you label A and B. If I wanted to, I could make that A and that B. The only thing that's always got to be the same is that length there, C. So I'll leave it in this the way I've labelled it here, and now I'm just going to punch the information into the formula. So we have got A, well that's 5, and I square that, plus B, which is 7, and I square that, and that's going to equal C squared. Okay, using your calculator, or if you know your squares, and I would recommend if you don't, then learn them. Squares of 1 all the way up to 15, and the square roots, and that's a GCSE requirement for foundation and also for higher. So 5 squared is 25, plus 7 squared, which is 49, and that equals C squared. And if I add those two together, 25 plus 49 is 74, and that equals C squared. So to find C, I must do the square root of 74, which, again, if you're familiar with your tables, you realise there isn't an easy square root of 74, so you're going to need your calculator. So the square root of 74 using your calculator equals 8.6 to 1 decimal place, and that is the answer. But unfortunately, my friends, this is not always what you're going to be asked. Sometimes they won't tell you one of the horizontal or vertical triangle lengths. So this would be the example. So here's our triangle with the sides labelled A, B and C. And just to illustrate how this is going to work, I'm going to use a triangle that we've already used, and I'm going to say the length of C is 5 and the length of A is 3, but we don't know what B is. But we are not going to sweat about this. Oh no, 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 no. We will be relaxed about it, because all we're going to do is punch in the numbers. So here we go. What do I know? Well, I do already know what A is. So I'm going to put in 3 squared plus. Do I know what B is? No, that's what I need to find. So that's just going to stay as B squared. And we then got C squared. Do I know what C is? Yes, it's 5. So I'm going to put in, I'm going to put in, it's not working, there we go, 5 squared. Now I'm going to work those things out. 3 squared is 9, plus, still don't know, B squared, equals 5 squared, which is 25. Now I need to rearrange the formula. and that will be in a different video, but whatever I do to one side I must do to the other is the basic rule of that. So how am I going to get, I want the b on this, what I'd like is, if I have my equal sign here, I'd like all the b's on that side, and I'd like all the numbers on that side. Okay, so that's what I'm going to try and do. So do I want that 9 there? No, I don't. How do I get rid of, how do I negate 9? How do I make it 0? Well, I've got to minus 9 it, because 9 minus 9 is 0. But whatever I do to one side of the equation, I must do to the other. So I'm going to put a minus 9 on that side of the equation. The b is already in the right place. I don't need to move it to the other side of the equal sign. So the b squared stays where it is. And the 25, that's on the right side. I don't need to move it over here. Don't need to do that. So the 25 is going to stay there. So b squared equals 25 minus 9. Well, 25 minus 9 equals 16. B squared equals 16. So therefore b equals the square root of 16. Square root of 16 is 4. So the value of b is 4. Look, there's the 3, 4, 5 triangle. So that all works, doesn't it? So a short introduction there into Pythagoras theorem. I'm going to do another video which is going through exam questions. I hope it's been some use and it has shed some light on it. Do you like, yeah, hey, it's all there. See that? Shed some light on it. And you don't feel that I've monkeyed around while I've been doing it. And most importantly, you've now got that in your toolkit of things that you're able to do in your exams. Okay. So that's it, everybody. This has been Saltash Maths Tutor. I hope that has been of help. And if it has, leave comments. If you want more, leave comments. And thank you very much. Goodbye.